very non-trivial claim that these two are the same operators. So that is what Bosonization fellows believe. So if they are correct, I should be able to prove this. That I take this operator, take the commutator with this, I get this. So I tried all this, and this is where I have reached. And I am simply unable to show that this is equal to PR CVR. So that is why we have been kind of forcefully claiming with Joy and I, when we wrote our papers, we kept saying it's a mnemonic. Even in my book with the dynamics of classical and quantum fields, if you read the last chapter, well, not the last chapter, 12 and 13, the last two chapters, I have forcefully claimed there that the Fermi-Bose correspondence in Bosonization is a mnemonic. But in 2019, with Joy and Nikhil Danny, both of them know that with we I had a correspondence with Duncan Haldane, where he showed me many proofs which are new to me, and I think they are also new to the community, which I'm going to explain in this series of lectures. And then it nearly convinced me that it is in fact this Fermi-Bose correspondence, this personalization, they are actually operator identities. So he almost convinced me. But then when I was preparing for this lecture, I got stuck here. So I sent him an email last week asking him to explain this to me, that where am what am I missing? So how do you prove this? And he's not responding, and neither are any of the other experts who are supposed to know this.
So,
Yeah.
sir, the beginning two terms in after the word are
Which
contains,
which which slide? Which slide? This one or earlier one?
yeah, this one,
Uh,
the last equation. So first two terms contains three operator, two annihilation and one creation.
yeah, that's because I have killed one of them through the commutator. No, see, this PR has two creation, two annihilation. When I take commutator, one of them gets destroyed. So there'll be like, if you take commutator, one of the creation disappears. So there will
So
be, hmm,
so initially I remember you said like during the condensed method course, like for the conservation of number, the conservation of the particles, there should be two creation, two annihilation operator. But this is quite
no, this is just some intermediate step in some calculation. It can have whatever it wants. I mean, just C itself has only create annihilation. So if the moment I write CPR, you will complain, is it? How can you write CPR? It has only annihilation. It doesn't conserve number of particles. So I am not even allowed to write CPR on a piece of paper, is it? I mean, what is your complaint basically?
so nothing. I just got it.
Yeah, I mean, you're not even allowing me to write any operator which doesn't conserve the number. I mean, I can write it. I should just not say that it's a part of some Hamiltonian. That's all. I mean, uh, this is some intermediate step in some complicated calculation. It can do whatever it wants. No, point is that this horrible mess should be this simple result. Then only Fermi-Bose correspondence and operator identity. I find that incredibly hard to believe. How can this horrible mess be this? I tried doing many things, it didn't work. So if you want to go further, the way we do it, how do we do this? Suppose you want to prove that this horrible mess is equal to P into CP. So what are the properties of CP? If you anti-commute CP with another CP, you should get zero. If you anti-commute it with CP dash dagger, you should get Kronecker delta PP dash. So if you are brave, you should try to do that. So you take this horrible mess and find the anti-commutator of this with CP dash and prove that it's zero. And then take this horrible mess, find the anti-commutator with C dagger P dash and show that it's anti Kronecker delta PP dash. I doubt you will be successful. Okay. I mean, on the face value, it doesn't seem possible. Unless I'm missing something very deep or I'm being absolutely stupid, whichever, I don't know which one. Mm. But right now, I'm not convinced. Okay. So my current stance, unless somebody demonstrates otherwise, is that this Fermi-Bose correspondence is just a mnemonic. That means uh, the claim that this is same as this should not be taken literally. So the point, this is a very serious thing because it's only when you take this literally then you can really go ahead and apply it the way people have been applying it to Rutinger liquids with inhomogeneous with impurities and all that. If you cannot take this literally, you have no right to apply it the way they apply it. So this is my serious objection to the conventional approach to bosonization, which is what led us to invent this non-chiral approach, which kind of never makes this claim that those. So we always insist that our correspondence is merely a mnemonic, which happens to reproduce the properties of free fermions plus impurities fully correctly. Okay. So it's just a way of parameterizing the properties of fermions using certain commuting variables. So that's how we think of bosonization. But these people adamantly insist that these are operator identities, and they keep using big words like, oh, this is part of mathematics literature, it's part of conformal field theory. You don't even know this, that. But they never show any proofs. It's only after insisted, then Duncan Haldane sent me lots of emails where he tried to prove many things. He was successful, of course, but I asked him for this proof that show me how this is equal to this. And he is silent, he's not saying anything, and neither are any of the others. So, unless they reply, I'm going to put my foot down and say that these two are not equal. Well, why should I believe they're equal if nobody proves it to me? I was not successful. So, I mean, science doesn't work that way, right? Because some expert says that it is true, I have to believe it. That is exactly what you should not be doing. Okay, anyway, I'll proceed. So, so for whatever it's worth, I mean, these two appear to be the same if you only focus on the commutator of this with the bosons. So in other words, if you kind of already decide in your mind that this chiral fermions are equally well described by these bees, then you say that, well, so long as everything commutes with the bees properly, then I am fully fine. Then you will go ahead and be convinced. But I believe that is a mistake. Because why should you actually believe that until why should you believe that the fermions are described equally well in terms of the bosons unless you have actually proved whatever I have asked you to prove here? Because it's not, these are not the same operators, I feel. I mean, it's obvious from this that these two are not equal. Finished. End of story. Okay, so now leave that aside. That so it sort of works in some sense. In what sense we'll decide later. But so how much time do I have? Already 6 o'clock.
Sir, it's already 6.
Yeah, so I can
So
stop
if
here.
you want to continue, you can.
No, I can. This is
Yeah,
a good place to stop because in the next class I will discuss how to introduce interaction between fermions because these rows can be described in terms of the bees, and then the kinetic energy is already diagonal in the B. So that's I mean, whatever I'm going to describe from now on will be less technical and kind of more pleasant in the sense that you can actually diagonalize interacting Hamiltonians, which was the original motivation for introducing this technique anyway. So it will be less technical and more enjoyable, but it will also kind of lull you into a sense of false understanding. You'll think that you have understood when all these fundamental issues are still in the background. You should never forget that there are all these basic issues that at least I have not been able to resolve yet. So you should still take all this with a grain of salt. Okay. So I'm going to stop here unless you have any questions.
Sir, I have a request. Can you please share the slides with us, if possible?
Yeah, I'm going to share the slides with you because it's the same PPT. I'm not changing. I'm just adding more and more slides as I go along. It's a long PPT, so it's kind of becoming longer and longer every day. So yeah, I mean till now whatever I've done, I'll convert to PDF format and I will maybe upload on Google Drive and send you the link if that's okay.
Yes, thank you, sir.
Yeah. So, are there any other questions? So, why don't you go ahead and you'll be doing everybody a favor if you can show that this is same as this. I mean, if use your brilliant IIT minds and actually show this. I'm not being sarcastic. I really want you to be successful in showing these two are equal. It's possible I missed something important, but I want you to actually do it. Try to see how you can fix this. That see if you can, write the PR in terms of the boson in such a way that when you find the commutator of PR with the fermions is the same as this bosonic form commutator with the fermions. So if you're successful, let me know. Okay. So think about all this very seriously because this is a very well established, or what people think is a very well established technique. There are literally 1,000 papers or more using this technique in PRB, PRL, all kinds of journals have published using this technique. And if this is the state of affairs, I am very disappointed. But if I'm missing something very obvious, let me know. Okay. So I'm stopping here.
Thank you, sir.
So
Yes,
whoever has recorded this, please send me the recording.
Yeah, yes, sir. I'll send you the link.
Okay, I am closing. Okay, bye bye.
Yeah, yeah. Okay. Okay. So thank you, sir. Thank you very much. Okay. So, go ahead, sir.